Today I start one important topics related to linear algebra. Especially we start some topics related to algebra. Okay, so also known about that means this one some scalar and vector. Okay, that means scalar obviously represents some magnitude and vector represent some magnitude and direction. Okay, we known about that in so many lower standard. Okay, that means too much lower standard we also discuss, and so many things we discuss related to this topics. So we also discuss in earlier stage. Okay, scalar and vectors. Okay, that means scalar represent some entity magnitude and vector represent magnitude plus direction. Okay, that means magnitude plus direction, then we call this one is vector represents some vector. Okay, and we mark this vector symbol this one. And otherwise if some magnitude represent, then we call this entity is scalar. Okay, then that means entity is scalar or vector depends on this. So we now going to discussion of that, and so many examples is here. Okay, now we also known about this one is vector and this one is scalar. So today we write here any entity involving both magnitude and direction. Okay. Magnitude and direction is called a vector. Okay, is called a vector. Now a vector is represented by an arrow whose length denotes the magnitude of the vector and whose direction represent the direction of the vector. Okay, so we write it in this way to easily we discuss today. A vector, okay, a vector is represented by an arrow, is represented by an arrow, okay, whose length indicates whose length indicates whose length indicates the magnitude of the vector, the magnitude of the vector, and whose direction represent the direction of vector, and whose direction represent the direction of vectors. Okay, represents the direction of the vector. Okay, direction of the vector. Understood? That means vector obviously represented by an arrow whose length indicates the magnitude of the vector and whose direction represents the direction of the vector. Okay, now we also further discuss about that. That means we also discuss some parallelogram law. Okay, we erase that portion and going to discussion of some parallelogram law. Okay, Parallelogram law. Okay, now this one is for vector addition. We also discussed today the the sum of, okay, the sum of two vectors x and y, sum of two vectors x and y, okay, that act the same point P, that act the same point P, okay, is the vector beginning at P, is the vector beginning at P, okay, and that is represented by the, that is represented by the, that is represented by the diagonal of parallelogram, by the diagonal of parallelogram, okay, having xy as adjacent sides, having x and y as adjacent sides, okay. So what we discussed today, that means the sum of two vectors x y, they act at some point P, okay, that means this point P here, y here, x, okay, this one x, this one y, here point P, okay, then is the vector belonging at P that is represented by the diagonal of the parallelogram, okay, this one represented by the diagonal of the parallelogram x plus y, okay, so that is represented by the diagonal here x plus y, and this one x, so this one obviously y, okay, not a problem at all. So now we write it in this way, okay, that means if we draw a figure in here in coordinate system, then this one x, this one y, and this one r, okay, x plus y, the x y here, x plus y, okay. Now we marked as this one is P, this one something, okay, Q R is, then PQ equal to x plus y, okay. Here we write this coordinate of this one, then this one is better. Then we also erase that problem and going to further discussion of that, okay. So we erase this one now and further discussion of some problem. In this way we write here two vectors, two non-zero vectors xy, two non-zero vectors x and y, two non-zero vectors x and y are called parallel, are called parallel if y equal to tx, if y equal to tx for some non-zero real number t, for some non-zero real number t, okay. Then we also discuss in this way, if the end point of x has coordinate a1 a2, then the coordinates of end point of tx equal to ta1 ta2. Okay, so in this way we represent all, and we also known about, that means, some operation. Okay, that means for all vectors satisfy this one, x plus y equal to y plus x commutative property, and here x plus y plus z equal to x plus y plus z associative property, and x plus 0 equal to x, and here x plus y equal to 0 inverse. In this way obviously 1 multiplied x equal to x, and we also discuss a b x equal to a of bx. Okay, and here we also write a of x plus y equal to ax plus ay. Okay, and same way a plus b whole into x equal to ax plus bx. Okay, so in this way we represent this property of vectors. Okay, now we also going to discussion of another one. Okay, that means if a line in space that passes through two distinct points a and b, then what happens, we also discuss today. Okay, that means two vectors are parallel. When parallel, then with this one we discuss. Now we going to discussion of some problem, which one obviously gives, that means the equation of a line that passes through two distinct points, then how we obtain this one. We erase that portion and going to further discussion of that. Okay, so what happened, what we discussed today, that means the line. Okay, the line in space passes through two distinct points, passes through two distinct points, okay, a and b. What we write here, that means we take o, let o denotes the, let o denotes the origin. Okay, denotes the origin of coordinate system of a coordinate system. Okay, in space, and let u and p denote the vectors that begin at o, and let u and v denotes the vectors, okay, denote the vectors that begin at o, and end at a, okay, end at a and b respectively. Then what happens, then obviously we write it now. If W denotes the vector begin at A and end at B, if W denotes the vectors begin at A and ends at B, okay, then what happened? Then obviously we write it now. Then tail to head, okay, that means solution addition shows that tail to head addition shows that what u plus v equal to w, okay, then hence w equal to u difference, so, sorry, u plus w equal to v, okay, u plus w equal to v, okay, hence w equal to u difference v, hence w equal to v difference u difference v not v difference u. How we realize this one? This one is that this one v a b o, okay, this one u, this one v, and then this one ab is w, okay, then what happened? U plus w equal to v and w equal to v difference u, okay, then what happened? Then obviously we talk about that, okay, that means since a vector multiple of w is parallel to w, okay, and then obviously parallel to w but possibly of different length from w, and any point on the line joining AB may be obtained as end point of a vector that begins at A and has object from TW for some real number T, okay, that means we also now discuss this one, then some parallel of this, okay, same thing we write it here, okay, then this one equal to what? V difference u, okay, equal to w. Then we talk about that the end point of every vector of the form a of the line a of the line through a and b, okay, is x equal to that means we write it in this way. We erase our portion and going to further discussion of that, okay, what happened here? That means thus okay, what we get? An equation of the form, an equation of the, okay, an equation of the line through a and b, of the line through a and b, okay, a and b is x equal to u plus tw, okay, x equal to u plus tw through a and b. Then this one is what? That means what we write? Equal to u plus t v difference u, okay, where t is real number, where t belongs to R and x be an arbitrary point on the line, and x be an arbitrary point on the line, arbitrary point on the line. Okay, then what is happen here, we also talk about that this one, that means here a b must be the end point of every vector of the from tw through a, of the that begins at a and lies on the line joining a and b. Okay, that means this one b a here, a b o u p here w. Okay, then w equal to what, v difference u. Okay, so what we call about is, that means the end point of every vector of the from tw means, that means parallel of this w. Okay, obviously obviously that begins at a and lies on the line joining ab. That means if this one begin at a, then this line contains this parallel line. Okay, otherwise any parallel, this one is different, then it's not begin at a. Okay, so we write in this way, x equal to u plus t w and u plus t v minus w. Okay, so we set one example to discuss this one in better way, and we obviously write it here, this one. Okay, that means since a scalar multiple of w is parallel to w but possibly a different length from w, and any point joining on the line a and b may be obtained as an endpoint of a vector that's begin at a and has of the form tw for some real number t. Okay, so we write in this way, that means we write it this one, then this one is better. Since, okay, since a scalar multiple, since a scalar multiple tw, okay, scalar multiple of w, scalar multiple of w, okay, is parallel to w, is parallel to w, and what happened, but possibly a different length from w, but possibly a different length from w, different length from w. Okay, and then what happened, then at any point on the line joining a and b, any point on the line joining a and b, a and b, what happened, may be obtained as end point of the vector, may be obtained an end point of the vector who that begins at a, that begins at a. Okay, and has the form tw, and has the form tw where t is some real number, where t some real numbers. Okay, not a problem at all. Then we call it this one, because an equation of the line through a and b, we write it x equal to u plus tw. Okay, so we also discuss this one in better way. Now we're going to one example related to that topics. Okay, we erase that portion. So we also discuss one line through 2 point. Okay, equation of a line in space passes through 2 points. We give some example. We write it here, examples. Okay, so what we write, let a b, okay, b points having coordinates, b points having coordinates, okay, -2, 0, 1 and 4, 5, 3 and 4, 5, 3 respectively. Okay, then the point of obviously the end point C of vector emanating from origin and having the same direction as the vector beginning at A and terminating at B has coordinate what? This difference, this. Okay, so we write it in this way. That means the end point, okay, the end point C of the vector, okay, emanating from origin, emanating from the origin and having the same direction at the vector, and having the same direction, as the vector beginning at A, as the vector, okay, beginning at A and terminating at B has coordinates, and terminating at B has coordinates, what? Has coordinates 4, 5, 3. Difference what? -2, 0, 1. That means these two coordinate difference equal to 6, 5, 2. Okay, hence what happened? Hence the equation of the line through A and B. Hence the equation of the line okay, through A and B, is what? Is x equal to -201 plus t into 652, okay, equal to 6t difference 2, here 5t, here 2t plus 1. Understood? I think this one is too easy, and we also discuss again too easily. Okay, now we're going to be discussion of some plane, okay, which passes through, that means 3 non-collinear point. Okay, we also discuss it today. Okay, so we erase that portion and going to further discussion of that. What happened? That means A, B, C are 3. Let A, B, C are 3 non-collinear points in space. 3 non-collinear points in space. Okay, Then what happened? Then these points are determined a unique plane, and its equation can be formed by use of our vectors. Okay, then these points determine a unique plane. These points determine an unique plane. Okay, now we're going to be discussion of that. Now we also write here, let u and v denote the vectors beginning at a and ending at b and c respectively. U and v denote vectors, okay, beginning at a and ending at a and ending at b and c respectively. Okay, then observe that okay, observe that any point in the plane containing any point in the plane, okay, any point in the plane containing a, b and c, containing a, b and c, okay, a, b and c, and is the end point is of a vector x, is the end point is of a vector x, okay, beginning at a, and having the form su plus dv. Okay, this one is small s for some s and t belongs to r. Okay, that means uv denotes beginning at a and ending at b and c, and then observe that any point in the plane containing abc is the end point is of a vector x beginning at a and having the form su plus dv. Okay, for some s and t belongs to r. Then what happened? Okay, then the end point of su is the point of intersection of line through a and b with the line through s, okay, parallel to the line through a and c. Okay, then what happened? Then for any real number s and t, the vector su plus tv lies in the plane containing abc. Okay, it follows that an equation of a plane so we write it here in this way, that means the end point of ACU, okay, the end point of end point of ACU, okay, End point of SU is the point of intersection. Point of intersection. Okay. Of the line through A and B. Of the line through A and B. Okay. Through A and B with the line through S. With the line through is parallel to the line through A and C. Parallel to the line through A and C. Okay. Then what happened? We erase that portion and going to further discussion of that. Okay. Then what happened? That means if a similar procedure for TV, a similar procedure for TV, okay, that means if the end point of TV is the point of intersection of the line through A and C, okay, with the line A is parallel to the line through A and B, okay. Then what happened? Then obviously for any real number, then okay, then for any real number, T and S belongs to R, okay, the vector SU plus TV, the vector lies in the plane okay, containing ABC, okay, containing A, B and C, okay. Then it follows that an equation of the plane containing ABC, an equation of the plane containing A, B, C and C, okay, is what? Is x equal to A plus SU plus T, okay. Where S and T are arbitrary real numbers, where S and T belongs to R, and what happened? And S denotes an arbitrary point in the plane, and X denotes an arbitrary point in the plane, okay. So we will also discuss this one also, okay. Now we erase that portion, and today I'll stop here. If you get this type of videos, please subscribe my channel, and if you gives like, please click on like option. If you have some comments, some questions, some suggestions, please write it in comment box. So thank you. I'll stop here, okay.